you guys do? Your education?
Well, I thought
Lunar lander looking thing.
Oh, you
Was
were
there crazy?
I thought it was pretty cool. You're saying it together.
I was just like working for it because
Yeah, besides being a
I was done with it. It was too complicated at the very beginning, and I was like, guys, we should dumb it down for it. They're like, no. And at the very end, we dumbed it down a lot, otherwise we wouldn't have made it. That's why it looked like a PowerPoint.
I don't know, man. Someone else that has like more control.
Ours ended up, we like,
Yeah, I mean,
we got like the, we didn't use that set we just used,
so nervous.
we used Fox 2D and then we drew everything with Qt because
Either you should just the job that you have now, you should just recommend.
we didn't have to use that set. I worked for the university.
Plan is to become a legend. Everyone
Yeah, so then I'll bring you guys in.
bring me in here. I need to get started.
Dude, did I tell you about my buddy that he worked with Dixie and got hired?
I think so, yeah.
All right.
I don't know where you got it.
So let's get started. So the first thing is just a reminder, phase 1 of your product is due on Wednesday. So I'd like to take a few minutes to open the floor for questions you may have regarding the design of your ER. Go ahead.
Do things like the fact that a driver has to have a unique ID need to be enforced in the database?
Driver has to have a unique ID. That's implied, right? A driver or user, Uber driver or Uber user, is a user of your system. Every user must have a login name, so login must be unique. So that's the key. So once you declare that's a primary key, the database will, of course, automatically enforce that. Does it necessarily need it? If that's, first of all, key is not of you specifying whether something is key or not. If spec says it's unique, then it's key, regardless of whether you want it to be key or not. Right? That being said, if you have more than one key for a schema, you as a designer have the choice of choosing one of them as your primary key. You don't have any freedom in deciding what's the key for your database, right? The key of your database comes from the specification. Does that make sense? For example, you don't decide, you don't get to say, oh, student ID is key or not. Student ID is always a key, regardless of whether you like it or not. But you can choose whether to use student ID or student login. That's two keys for the same schema. You can choose, you have the choice of choosing one of them as a primary key. Does that make sense? Any other questions? Go ahead.
So I just, and maybe I just didn't read the specification good enough, but like, so you have like reserved, like car reservations, but
Yes.
then you also have like car rides.
Car ride,
And so like, could say user A reserves car B from like 1 to 2. Could user C then go in and enter in, hey, I've taken a ride from 1 to 2.
Yeah.
That car was
Yeah.
there.
So if you read the spec, towards the end of the specification, it says for phase 1, let me pull that document up. So it says we do not require you to enforce we do not require you to enforce constraints while constraint checking or trigger. Rather, you can enforce any distance rules, if any, in your application level code. Meaning that in phase 1, you do not have to worry about those constraint checking as you were just mentioned.
Okay.
As you have just mentioned. That make sense?
Yeah.
Okay. Question over there?
Should hours specify the car?
Should say again?
A driver working certain hours,
Yeah.
should it specify what car he's in?
Okay, I see what you're saying. So you are saying a Uber driver may have multiple cars, and and the spec says a Uber driver should be available over potentially multiple periods, right? During a day. Should that availability attach to a particular car or attached to the Uber driver? Does that make sense? The spec didn't specify one way or another, so it's up to you. I think a simpler design is to say the availability is with a car rather than with the driver itself. Of course, you can also say availability is with the driver. Then you somehow introduce a relationship to attach the availability of that driver with one of the cars he or she owns. Does that make sense? So, in other words, you have Uber driver, right? You also have Uber car. So by the way, the fact that you're gonna specify Uber driver is available multiple periods indicates that availability, the hours of availability for Uber driver should not be an attribute of Uber driver. Because if you treat it as an attribute, like you're available from hour 1 to, for example, hour 2, so this specifies a period, right? What that means is you limit the Uber driver to be available only for one particular period during the day. Because you can only have one value for this, one value for that. Does that make sense? This is the same as, remember in homework 1, and also in our lecture, we talk about an employee works for a department, but potentially can work for the same department over multiple different periods. Can someone tell me how we address that issue over there? How do we model the fact that an employee may work for the same department multiple times? Go ahead.
Make the time period
Exactly. Make the duration, the time, the duration for which an employee works for a department as a separate entity set. Remember that? That's in your homework 1, right? So same here, you wanna make this a duration. Right? You introduce a duration ID, hour 1, hour 2. Duration ID is key, right? So each duration has a start time and time, right? Does that make sense? So far so good? Yeah. Now back to your question, there are 2 designs that's possible, right? One is to say this is available at, so you introduce a relationship set like that, and this is the many-to-many mapping. A Uber driver can be available for multiple durations, and a duration can have multiple Uber drivers available over it. So it's many-to-many mapping. Does that make sense? So that's design choice number 1. Do you follow this? But a potential limitation of this design is when you have a relationship connecting one Uber driver with one particular duration, you know that Uber driver is available for that period of time, but you don't know if this guy owns multiple cars. That's many-to-many. Let's suppose each Uber driver may own multiple cars, but each car is owned by just one Uber driver. Okay, so this obviously must be a one-to-many mapping. And there, of course, a total concentration constraint here. You don't know when he or she is available, which car he or she is going to drive. Does that make sense? All of you follow what I'm saying? The spec didn't really ask you to check that, so I would say, if the spec doesn't specify that, then you don't have to worry about it. This is okay. You assume that when he or she is available over that time, he or she can just use one of the cars to drive. Right? Now, another design is to say, okay, even though the spec says, you want to specify when a Uber driver is available, but that kind of implies that the availability is attached with the car, one of the cars he or she owns. So you say, this Uber car is only available during this period of time. Does that make sense? That's another way of modeling this. Either is fine. I would say, I probably just go with, the Uber driver is available. Assuming the cars are always available to him or her, then whenever he or she is available, he just choose one of the cars to go. Like if you make a reservation on one of the cars he owns, she owns, and during which the driver is available, then it's okay.
The second way that you propose doesn't restrict the Uber driver being available for the same.
Yeah, of course. I mean, if the availability duration is attached to Uber driver, that implies that Uber driver must be available for that period of time, right? So even though it's attached to the car, but kind of
you can have multiple, double schedule Uber driver.
What do you mean double schedule? You mean Uber cars, multiple cars he owns can be available for overlapping times? As I said, that's a constraint that we don't check in phase 1. I just said that, right? So you don't have to worry about that. Okay. Any other questions? Go ahead.
Is an Uber driver an Uber user?
Well, whether they are mutually exclusive, the spec didn't specify that. So yes, Uber driver can potentially also register as Uber user if he or she wants to. Does that make sense?
Without making a new account?
Without making, well, in that case, it depends on how you want to model this. I would say from entity point of view, then that's obviously a hierarchical. You're going to have something like this, right? Right? So basically your question, I will say this, I will give you this as a hint, right? Basically you design boils down to whether you want to allow or disallow overlapping constraint or not. That will further imply whether if he or she wants to be an Uber user, whether he or she needs to register another account. Right? So it depends on whether you want to specify over. Either way is fine. I mean, it's up to you. Whether you want to specify overlapping constraint is true or false.
Some clarification. When you put the UID on duration.
Which one? This one?
No, that one.
This one. I put DID, duration. I introduced a new identifier to identify the duration entity. Yes.
That should be a foreign key to the Uber driver, right? Or
foreign key to Uber driver. You are saying if I convert that corresponding relationship set to a table? So first of all, there are no foreign key in a ER diagram. I hope you know that, right?
Yeah.
So if you are saying available, and this is the many-to-many, then no, you don't take this to the table for the Uber driver. For many-to-many, that relationship set goes to a table by itself, by taking the keys from the two participating entity sets.
Why would you do that as a many-to-many? Like, does that mean that Uber drivers can share this? Is that to restrict items in duration?
I'm available from 9 to 11. Another Uber driver can be available at 9 to 11 as well.
So you just use the same.
Yeah. Why you want to store that same duration multiple times?
Could you make like H1, H2 like combined as a key then if you're going to do that rather than?
Yeah, you can, but if you do that, then when you convert this to many, you are copying two attributes rather than just one. Right? I mean, it's easier to, I think, intuitively having a key here is better in my opinion. But yes, of course, you can drop this and just make a combination of this other key. Yes, of course. Okay. I think I have to cut this off by another. I'll take two more questions. How about that? Okay, then I'll take this off now. Yes.
Following that same reasoning, would you have the same ID in the Uber driver table and the duration table?
Would you have? Say again. Can you repeat the question?
In the Uber driver set, would you have ID, and then in the duration set have the ID?
Oh yeah, of course you can have same ID values, but in different tables they have totally different semantic meanings. I have a course ID, I have a student ID. This value can be same, but under different columns they mean totally different things. That's totally fine.
What I'm wondering is like whether or not you want the ID with the Uber driver or their duration. Where would you store it and why?
No, I don't get a question. Can you repeat the question? Like I can have a Uber driver ID, right?
Right.
I can have a duration ID, something like that.
Okay.
You gotta when you create duration ID. When you want to create this table, you may, I think what you're saying is now have two DID columns. How do I distinguish that? You call one DID like driver DID time. You can rename them. Then once you reference back, they still know that, oh, this attribute reference back to this attribute, this reference back to this attribute. Question over there?
So the duration, rather than having a unique ID for it, can't you make it a weak entity so it uses the Uber driver's ID?
Yeah, you can, but I see what you're saying. But as I said, actually, one of you asked this question in homework 1. I clarified that for the purpose of this course, I dropped the entire discussion of weak entity because I think it's a little bit confusing and doesn't serve, enough purpose to kind of worse the discussion of it. So I would say just, don't bother with that. Okay. Okay, I make an exception. Take one more question. Last question. Okay, go ahead.
Sorry.
No, you're fine. Go ahead.
So can Uber users rate, should they be able to rate both drivers and cars?
Well, don't think about what we do, don't relate what we do with the real Uber app, okay? The spec only says rate the car, then rate the car. So the spec said nothing about Uber user rate of Uber driver, right? The spec never said anything.
Well, in the assignment it does, in these, I guess the paragraph above, all the different subsections, it does say that there should be Uber driver rating. But then under the opinion subsection, it says that we should rate the...
Oh, but if you look at, I clarified that. If you look at, I cannot find where it is, but if you read the spec carefully, what I specifically clarified over there, when you calculate the rating for Uber driver, is the aggregation of all the cars he owns, the ratings you have received for all those cars, you aggregate those. You use that as a rating for the Uber driver. Does that make sense? I think I clarified that. Okay? Yeah, I specifically the clarification is right behind it. Read this, please. Defined by the average scores from all feedbacks a Uber driver has received for each of her Uber cars. Right? Right over there. Okay, so I will resume with the discussion on the slides. So we are done with basic SQL. So my objective today is to finish the discussion on SQL, except maybe how to interact with the database system through a third-party language like Java. I will do that on Wednesday, so you are ready for phase 2. Okay. So, but the purpose of today's lecture is really to wrap up the discussion on SQL. Okay. So we're done with the basic SQL. Next, I'm going to talk about some of the advanced features in SQL. The first thing we want to do is aggregation, right? So this is one place where SQL advanced the features we have seen from relational algebra. Right? In relational algebra, we notice that there are no aggregation operator at all. Right? Henceforth, in order to do things like the rating with the sailors with the smallest rating who reserve a boat, you cannot use operators such as minimum to find the sailors with the minimum rating. Rather, you have to do a self-join. Think about the example we did, right? You have to do a self-join to find the rating, the sailor with the smallest rating. In SQL, the people who design, those folks who design SQL decided to introduce aggregation because this really is a useful concept, right? So here are some very simple examples, right? Count, sum, average, max, and min, right? It looks pretty straightforward. However, there can be some, tricky scenarios where using an aggregation operator is not so straightforward. Let's look at some straightforward cases first. Find the number of sailors. That's easy. Find the average age of sailors whose rating equal to 10. That's also quite straightforward. Now look at the last one. How many distinct rating values sailor name equal to Bob have received? So the idea to understand this is each of the select from where block so this is a simple block, right? Simple SQL block. This block defines multi-set. Why a multi-set? Because we talked about this many times. By default, projection in SQL, which is the select clause, does not remove duplicates. Does that make sense? It does not remove duplicates. So this actually defines a multi-set. So aggregation over this, if you have aggregation over this, some aggregation operator. The way you understand this aggregation is that I will simply apply this aggregation over. So this is essentially I'm applying this aggregation over the master set A. So that's the way you understand all these aggregation operations in SQL. Okay. With that being said, let's look at how we understand this one. So first of all, ignore the aggregation operator itself. That's your aggregation operator. Look at the select from where clause. It defines a Marquez set. What is a Marquez set? The Marquez set is all the sailors named Bob. Does that make sense? Right? And specifically, I'm interested in the rating value. So you get my A in this case is a Marquez set of rating values. 5, 7, 7, 5, 10, 8. Why? There's one sailor named Bob with a rating 5. There's another sailor named Bob rating 7. There is yet another sailor named Bob with rating 7. Because you may have duplicates on the name value, right? And so on and so forth. Does that make sense? Do all of you follow this? Now, then I apply count distinct over this set A. What do I get? First of all, you do distinct, which means that you want to eliminate duplicates. So your final answer is simply what? 3 in this case. All of you follow this? Now, if I change this example, I drop the distinct keyword, what do I get? Huh? Oh, the answer should be 4, by the way. Yeah. If I drop the distinct, what do I get? I got 6. Okay, so that's a simple illustration. Question over there?
Is distinct part of the aggregate operator?
Yes, you can think distinct. To be precise, distinct is not considered as an aggregation operation. Distinct, the purpose of distinct is to remove duplicates, but it can be used in conjunction with an aggregation operator. That's a more precise clarification of what's going on. Question over there?
How does distinct choose which ones they are doing?
How do you distinct choose?
Well, yeah, how does it choose somewhere they are? Does it just like whichever comes first?
Whether you apply distinct first or whether you apply aggregation first. When you use distinct keyword with aggregation operator, you always use the distinct operator first to remove duplicates. Then you apply your aggregation operator.
Okay. I was talking about like if they choose between the first 5 and like the second 5, like how would it choose?
Oh, that doesn't matter, right? For aggregation operation, which 5 you choose doesn't matter. No, doesn't matter. Right? Okay. So that's for this example. Now, let me ask you a question. Okay. If I change this to this, okay, having distinct and having no distinct, consider those two queries, right? Are the results going to be the same or the results will be different? Sailor ID is the primary key, right? So of course it's unique. Yeah?
So you would have one.
Yeah, so it will have no effect at all. You only have one sailor to be returned, meaning this set A is a set of single values, so having distinct and having no distinct in that case will have no effect whatsoever. But if you use name, things change because name is not a key. Okay? So I just want to use this simple example to illustrate what's going on. It looks like aggregation is like simple, right? But it can be tricky. For example, let's say I want you to find the name and age of the older sailor. The name and age of the older sailor. So it's tempting to do a query like this. I find the name and the largest age value from sailors. Does that make sense? All of you follow what's going on here? Let's try that on a real database and see what we get. So for the student table, I have student ID, age, and student name, just like the sailor table, right? I'm gonna do exactly that query I just showed you, which is select as name, the max of age from students, right? And if you run this query, what do you get? You think you're trying to get the name and age of the oldest student. But let's execute this query, see what we get. It actually complains an error back to you. You cannot even execute this query. Does that make sense? Now, if I remove the name attribute from the projection list, this simply finds the value of the oldest age from all the students you have. Does that make sense? This is okay. Now let's look at the error message carefully. In aggregate query without group by, we haven't talked about group by yet, so you can ignore that. So basically, this obviously is an aggregation query. So the underlying engine recognizes that. Expression 1. It's too long, this message, I cannot see it. This is incompatible with whatever, right? Basically what it says is, in an aggregation query, if you have an aggregation operator and a non-aggregation operator, that's what's going on here. If you have an aggregation operator and non-aggregation operator, you cannot put them together. That's essentially what the error message says. On first look, you may think this is weird, but if you think about it, it actually makes a lot of sense. Why? Let's go back to the semantic I just mentioned, right? So, what you're trying to do is, if you put another, whatever attribute here on top of this aggregation operator, let's say small attribute A, with this aggregation operator, right? What's going on is you're defining an aggregation operator over this market set A, which is, by the way, give you a single value, because it's an aggregation operator. Does that make sense? And what's this A over A? And you are trying to pair this with projection out of A, which is a set. This gives you a set. Without this thing, this actually is a market set. Does that make sense? Do all of you follow what I'm saying? So you're telling the underlying engine to give you something that's a set together with a single value. Obviously, the two are non-compatible. You cannot put them together. You follow the rationale I just gave you on this? So it doesn't work. That's why it doesn't work. Question on this? Now, how do we solve this problem? Well, the idea is, okay, I'm going to just use the engine to show you how to solve this, right? So my objective is to find the student's name with the oldest age value, right? So what I will do is I will use a nested query. I will say select student name from student where my age value is equal to what? Okay? Take a minute, look at this query, right? So it's a nested query where the inner block will return, in this case, 99. I just showed you, right? The max age value is 99. So you take that 99 as a value, then you loop through all the student record, and you output all those students whose age value equal to that max age value. Of course, there could be more than one student who have that max age value, right? Then you output all of them. because there's a tag. Right? I never tell you how to break a tag, so you output all of that. Does that make sense? Now let's execute this query, see what we get. Okay, I made a mistake somewhere. Select last name from student where age equals select. Say again?
Extra parenthesis at the end.
Yes, yes. Okay, so you got one student who is at age 99, right? One student, only in this case, there are only one student at age 99. Okay, let's try this with, for example, find the minimum, the youngest student's name. Right? That's how you do this for you. Of course, in this case, in this particular instance, there's one output, right, in each case. But potentially, you can have multiple outputs, right? I have explained. Okay. Another way to solve this query is that. So this is one way to do this, right? Another way to say is to solve this query is to say, okay, I'm gonna do. You're gonna be greater or equal than all of can you guys see this? Right? So basically you in the query select the set of all age values, all possible age values. Then your outer block says I'm gonna select the student whose age value is greater than or equal to all of that. In other words, you must be the student with the oldest age value. So these two are equivalent. Does that make sense? So let's run this query, see what we get. So the student with the max age value is named as long last name A. So you get the same output. Okay? Now let me, question?
So are those equally as efficient?
Are they equally efficient? How about I answer that question later on? Yeah. To answer that is that I have to open the door to a lot of other discussions. Right? So later on we will have some discussion on the inside of the kernel. At that time I will come back. Remind me to come back to visit this. Okay. Now I'm gonna change this query a little bit. I'm gonna change this to any. Can someone tell me what this query does? Go ahead. Yes, I'm gonna change. Yes, this will give all the students. Let me change it to this.
It'll give you all the names except the youngest.
Yes. Yes, it will give you all the names except the youngest student. Okay. Because any means that for that set, the condition only needs to be true for one of the elements in the set. All means that the condition must be true for all the elements of the set. Right? So that's the difference of the two. Fantastic. Okay. Now let's move on. So I have both ways of doing this here. Okay. Now, next I'm going to introduce the concept called group by and having. Okay. So group by and having is really an important concept because you often need to do things like, for example, find the age of the youngest sailor. Just now we said, okay, find the name of the sailor at oldest age. What if I ask you to do the following? Find the name of the oldest sailor for each rating group. For each different rating group, find the name of the oldest sailor. I just change in the query from the last slide. Essentially, there's one group, which is the entire sailors you have. What if I want to subdivide them into different groups and do the same thing? As another example, which is find the age of the youngest sailor for each rating level. Suppose I have rating from 1 to 10. This is similar to say, okay, I want to do a for loop such that I do this. You follow this? However, in SQL, you cannot do this for loop thing. Right? You cannot do this for loop. And if you don't have for loop, you say, okay, that's fine. There are only 10 values. I'm going to manually type this query, copy paste 10 times, and change I every time. Does that make sense? that works if your domain size is small, right? Like in this case, the domain size is only 10. What if, you know, the reading is from 1 to 1,000, the possible reading value? Then you need to type 1,000 SQL blocks, even if you do copy paste, that's too much, right? So is there an easier way to express this without relying on a for loop nor copy paste? Right? That's kind of the challenge we're talking about. Do all of you follow this? Let's see how we do that. So the idea is to use this concept called group by. The syntax of group by is as follows. You still have the select from where clause. That's the same as before. That define a set for you to apply either aggregation or projection over that set. That's what select from where clause does for you. Does that make sense? Okay. Now, if I add the group by keyword, it changes the syntax as follows. Before you do the select clause, before you do the final select clause, the select clause is to do either projection or aggregation, right? That's what select clause does, right? Either a projection or aggregation. So far, right? That's what select clause does, right? So so far, if you think about the sequence of actions that take place, is the follows. You take all the relations from the from clause, you produce the cross product of those guys, of those relations in the from clause, then you check for every single record in the cross product against the where condition, and you eliminate those do not satisfy the condition. For the remaining set of records in the cross product, you apply either a projection or aggregation. That's what's happening so far. Right? Now with group by, it changed the sequence a little bit. You still do your cross product, check your condition using the where clause, but before you do the final projection or aggregation, before you do that, after the where clause, what do? You partition them, you partition those remaining records in the cross product, meaning all those records who satisfy your where condition. Those guys, you partition them into different partitions, or in other words, group them into different groups. For example, all CS students go to one group, all math students go to one group, all history students go to one group. If you are doing a group by with, for example, department name. Of course, you can apply different grouping conditions using the same example, right? Let's say I can group student age at 18 into one group, student age at 19 into another group, student age at 20 to another group if I do group by age. Do all of you follow this? I can even use a composite grouping condition. A composite grouping condition means that it's a group by with more than one attribute. For example, I can group by department name and age. What happens is I first group CS student into one group, math student into another group, history student into another group. Then within each group, I further divide them into subgroups by their age values. Do all of you follow this discussion? Okay. Yes, question?
Does it only group by identical values, or can I be like, put 1 to 5 in this bin, put 5 to 10?
Oh, you mean can I group by, instead of a single with respect to atomic value of attribute, can I group by a range? Yeah. Is that what you're saying? So in the current discussion, no, because you are grouping by age. However, in database, in SQL, in most commercial database engines, they allow you to define a customized data type. You can define a customized data type, and that data type can be a set value. In that case, you can define a range as you customize data type. You can group by with respect to all possible range values. Then you can do things like that. But that's like more advanced feature. You have to define customized data type first. Does that make sense? So for example, I define a customized data type called range. And my range has 4 values. First value is 1 to 5. That's defining one range. My second value for the range data type is 5 to 10. Now if you do a group by with respect to that customized range data type, it will be grouped according to that range. Does that make sense?
Yeah,
but
get it
Yeah, but for now, let's consider atomic values, meaning that we're grouping by attributes with atomic values. So now what's going on, essentially, if I continue from the discussion here, really what's going on is you have a marked set A that defined by this select from where clause, and you add another group by to it. That's a small attribute A. What happens is this set of records A will be basically grouped into a set of different groups, A1, A2, until maybe AM. Suppose A has, this attribute A has M values. And this is essentially any records in A1, any record in A1, it must be the case that R.A equal to small a1. And the same is true for the other cases. Of course, you change the subgroup. Meaning that for the last group, any record in AM, the Mth group, their attribute on A must equal to small am. That's what's going on here. Do all of you follow this? Do all of you follow this? Now, I can still have my aggregation or projection at the end, but before having group by, that aggregation or projection happened over this set A, right? Now instead of applying them over this set A, what do you do? What do you do? Make a guess?
Applying over the groups.
Each of the groups.
Yeah, each.
You apply this over each of the groups. So your final output is what? It's a set of records, one per group. That make sense? Okay. That being said, there is a subtle constraint. And that constraint is the same as what we have seen just now, which is this. Remember, this example doesn't work. SQL will complain error for you. Now imagine I have this set of groups, right? And I said you're going to apply this projection over it. Now, I'm going to take over from over there to here, right? What's going on is really you are projecting out, for example, in this case, I'm projecting out this aggregation, this attribute A, and aggregation over all the records over this set A1. And I'm doing this over and over again for M groups. Does that make sense? Do all of you follow this? Okay, that's what I'm doing. This obviously is okay. Essentially what that means is for all records in A1, I apply this aggregation. I got one final value. So this will produce one value. This will be another one value. So on and so forth. And this, what about this? Does this produce a set or a single value? Using the projection semantics, if you do not remove duplicates, it produces a set. However, note that I'm doing projection over this value A, and I'm doing the grouping by with the value A. What can you say about this attribute for all records in A1? What can you claim about that? Well, all records in A1, their attribute A equal to A1. Meaning that they have the same make some space for it here. Meaning that they're going to have the same value on this attribute. After the projection, you will duplicate, it reduces to what? Just a single record. So this is still one value. So you have one value here, one value here. You got a pair of values as output for this group. Does that make sense? Do all of you follow what I'm saying? And this one value is essentially A1 for this group, and this will be A2, this will be AM. Because all records in the same group will guarantee to have same values because you are doing grouping by with regard to that attribute. They have to have same values to end up in the same group to begin with. Okay, now let me change this a little bit. Let me change this to B, attribute B. My grouping is still done with regard to the value A. Now what happened here? Look at what happened here. What happened here is you're doing this. Now you have a problem. Can someone tell me what problem we have if we do this? Can someone tell me what problem we run into if we do this? It's the same problem as what we have here. Go ahead. Yes, you got a set for this projection over B, and you have a single value for aggregation. It's just as what we're doing here. I just said, right? What we're doing here is project out the student name over student, and we pair that with a single value, which is the max age. This is a single value, and this is a set. Henceforth, a complete error for you. What you are trying to do here is identical to what you're trying to do over there. Does that make sense? You're projecting out a set of values. For all records in A1, I'm going to project all their B values. And their B values, there's no guarantee it's going to be the same. You may wonder why it was okay to project out A, but not B. That's because you group by A. If you group by A, all records in the same group will guarantee to have same values with respect to attribute A. But they're not going to have same values on attribute B. All of you follow this? Now, that being said, now you understand why we have this constraint, that once you have a group by condition, then the target list, which is you select clause, your target list must contain the following: a list of column names, either with an aggregation operation or attribute from the grouping list. Nothing else. By the way, if I group by A and B, if I change this to group by A and B, can I project A or B? If I change my grouping to group by A and B together, can I project out B here? I'm going to say yes. I'm going to say no. What about the rest? Okay, so I will ask you to, you said yes, right? So you answered the earlier question. I will ask you to continue with this. Why you can project out B if you group by A and B?
Because for each of those partitions, you project out B, then it's guaranteed to be a single value.
Yes, but fundamentally, if I allow me to backtrack one step in your mind, the reason is this reduced to a single value is because all records in A1, or for that matter, A2 to AM, all records in any of this set must have the same B values in order to be in the same group. Not only they have the same B value, they also have the same A values. So you can put out either B or A, that's okay. But you cannot put that out, for example, another attribute C. That would be not okay. Okay?
Would you more specific example? Let's say you
Group by name and age.
Yes.
So all students in the same group will have the same name value and age values. That's why it's okay to print out either name or age, or both of them. But it's not okay to print out the rating if you group by name or age, because students in the same group may have different rating values. That's a set. Okay, that's a special example I gave you. Okay. So now let's look at to run an example, I'm doing group by over ratings on sailors. I find the minimum age and rating values. And this query is okay because I do the group by using rating. That's why I can predict out the rating attributes. Because all sailors end up in the same group are guaranteed to have the same rating value. After I do the projection, they reduce to a single value. And aggregation reduce to a single value. So for each group, you have 2 single values to be output as a pair. That's okay. Okay? What about if I want to add additional conditions to my, before I do my group by? That's okay. You can add a where clause. And the where clause is executed before you do the group by. So you eliminate those sailors younger than 18 before you do the partition over them. Yeah?
Sorry. So I was kind of confused about that. So why couldn't you get select s.h since you're grouping by rating? If you want to see that age specifically out of that group.
If you select age, what do you get? You get, for each group, for example, let's look at rating 1. For all students with rating equal to 1, this average sailor age will reduce to a single value. What about the age? Their age value, it's a set. How can you output a set with a single value? It's the same as the arrow you have just seen from here. Can you see my screen?
No.
Just like this, if you understood what we said earlier, why it doesn't allow you to do this. It's the same thing. You're doing, it prevents you from doing this at the entire table. Similarly, you cannot do this over every single group. You're trying to produce a set with a single value. It doesn't make sense. That's why it prevents you from doing this, right?
So if we did want to get a single value for specific groups, it would be a different word?
Well, either you use aggregation, or it's part of the grouping list. So that all records in the same group will guarantee to have the same value for that. Okay? I think I will take this offline. If you are still confused, you can talk to me about it. Okay? Okay? The reason you cannot predict out age is exactly the same reason as why you cannot execute that query over the entire table. The entire table is viewed as one single big group. Okay? All right, let's move on from here. Conceptually, what's going on? Let's look at this query. Right? That's my input. I eliminate all the sailors younger than 18. So this guy is being eliminated. Not only that, I focus on what I care, which is rating and age. So I remove name and all that because my query, anywhere in my query, I never mention name and seed ID. So I remove these 2 columns. I eliminate this. What do I got? So I got the remaining record. I got the remaining record. Rating equal to 1, rating equal to 7, rating equal to 8, and rating equal to 10. But this record is being eliminated. That's what I get. And I also group them so that how many groups I have in this case? Can someone tell me? How many groups I have in this case? 4, right? You have 4 distinct rating values. This is one group. This 2 goes to one group. This goes to a group. This goes to a group. So you have 4 groups. That's your final output. For records in the same group, for example, this 2, the rating is guaranteed to be the same value. That's why you can predict this out. But imagine if you try to predict out the name from each group. You have 2 sailors rating at 7. One is Horatio, one is Dustin. When you predict out a set with single value, how do you make that work? You cannot make that work. That's why you cannot predict out the name, but it's okay to predict out the rating. Predicting out the aggregation is always okay because no matter how many distinct values you have, after applying an aggregation operator, it reduces to a single value to represent that group. So that's okay. All right. Find the number of reservations for each red color boat. So to do this, where you do a join between boat and reserve, make sure color equal red. After you have done that, you group all the records by their boat ID. This shows how many reservations record you have for a particular group, which is each group talks about a single boat, because you are grouping by boat ID. Then you return the count. This is an example of grouping over a join or two relations. I'm going to run a simple animation to show what's going on here as well. So this is the cross product between boat and reserve after I remove unnecessary attributes, like name of the name of the boat, the date the reservation was made, and seal ID. I don't care about any of those attributes, so I only keep the ones I care. This is from the cross product between boat and reserve. I haven't done anything else other than the cross product itself and removing unnecessary attributes. Step number 1. That's essentially the from clause. Does that make sense? After this, what do? You check the where condition, BID equal to BID and color equal to red. What do you get? You get only this one record. And you apply group by over this. Obviously, you have one group with a single record, so the final output is just this one. Print out the boat ID and the count. Okay? Now, next, we're going to introduce having clause. So suppose I want to do the query as before. I want to find the age of the youngest sailor from each reading group. Same thing as I've done before. However, for example, like using Olympics as an example, I want to find the age of the youngest athlete from each country participating in Winter Olympics. That's a group by country, minimum age, that's it. However, I only care about big countries, meaning that a country that sends more than 20 athletes to Olympic. Do you follow this? So I want to find the age of the youngest athlete from each country at Winter Olympics. However, only do this for countries with a large enough representation as the Winter Olympics. How do we do that? Well, if you think about it, we are imposing a condition. We are imposing a condition over these groups that you have produced from this set. You are imposing a condition over these groups before you do the final projection over these groups. For example, these are athletes grouped by country, right? Country 1, country 2, country N. You group by country, right? Now, before you find out the minimum age from each country, you say, okay, I only care about those big enough groups, meaning that the size of this must be larger than some value. So it happens after the grouping, but before you do the final projection, before you do the select. And this is something, if you think about it, cannot be achieved using the where clause. Why? Because the where clause checks for condition at record level rather than at group level. And it happens before you do the grouping. So you cannot possibly do this using the where clause. All of you follow this? Okay? So you can only do this after the group by. Hence, we need something additional. That something additional is called the having clause. The having clause is similar to a where clause in the sense that it allows you to specify a Boolean expression to check. However, it differs from the where clause in a significant way in the sense that the Boolean expression specified in the having clause is checked at the group level. The Boolean expression for the where clause is checked at the record level. That's a key difference of the two. Henceforth, one happens before you do the group by, the other happens after you do the group by. Do all of you follow this? Okay, let's look at one specific example. Okay, find the age of youngest sailor with age at least 18, and for each rating with at least 2 such sailors. Meaning that you are trying to find the younger sailor for each rating group, but you only care about those rating groups with at least 2 sailors. If the rating group had 1 sailor, that sailor automatically is a younger sailor, which is not interesting. That's why I don't consider it. Does that make sense? So that's essentially what this query does. Now let's run through an animation over this. This is as before, right? I take the table. This is essentially my quote-unquote cross product. In this case, I have a single table in the from class, so the cross product is itself. But then, of course, I remove unnecessary columns, such as name and field ID. So this is essentially is the cross product. In this case, it just gives you the relation back, because it's just one relation. Do all of you follow this? Then I do the group by. I have 4 groups. Among those 4 groups, only one group will satisfy my having condition, which is a group with rating equal to 7. So I explicitly show you the condition you want to check for the having clause, which is the count. So your final output is 1 pair instead of 4 pairs of values. Okay, compare this against the example earlier. Question over there?
Is the count column created by the group by?
No, not by the group by the having clause.
Okay. So we're having to make a count and then also, okay, I see.
Now, that being said, just like we have the constraint for the group by clause, where if you try to project out something from each of the group, that something has to be either a grouping attribute or an aggregation attribute. We explain in length why that has to be done, right? Because you cannot combine a set of values with a single value for each group. Similarly, for the having clause, the condition that you try to specify for the having clause has a constraint as well, has a similar constraint, which is to say the attributes you use to express any condition for a having clause has to be either an aggregation attribute or a grouping attribute. Why is that? Because you are checking that condition at the group level, which means it has to be a condition that's true for the entire group as a whole in order for you to check it. So aggregation makes sense, because no matter what the group looks like, after you apply the aggregation, it becomes a single value, which means you can check it at the group level. Grouping attribute is okay. Why? Because all records in the same group will have the same value. Yes, you can check that at group level. For example, I can change this condition to I can do this. This makes sense because you can check this condition at group level, because each group is guaranteed to have the same values on the rating attributes. That's why I can do this. Now, if you do this query, what's the output? The output will be empty, right? Even this will be eliminated. Because I check at the group level. This satisfies that first condition, but none of this. This too satisfies the second condition, but none of the groups satisfy both conditions at the same time. You already follow what I'm saying? Now, look at what I'm going to do next. I'm going to do 2 things next. Both are really important. So take a good look at this query. I'm going to modify this query, okay? What I'm going to modify is, first of all, I'm going to do this. Can someone tell me whether this query will always give same output as the earlier query I showed you, which is put the rating quiz on A to the having clause? Are these 2 queries giving you the same output all the time? Huh? Do you guys follow my question? Yes, go ahead.
I don't think so.
You don't think so? Okay, why?
If you have 2 sailors, right, and then one has a rating higher than
you will get the younger one. But it depends on the rating of the younger one as well, right? So if you think about the two queries, right? The two queries are very different. What happened in both queries are very different, but at the end of the day, their results are guaranteed to be the same. Let me explain why. For this query, what happened is you eliminate all those records. I'll continue with this. Okay, if you do this, what happens? This is not even in the, suppose this is my where clause, this is the after the from clause, right? Now before you do the grouping, I will apply the where clause, which means that this will be eliminated. This will be eliminated. So only this record will participate in your where in your group by clause. Does that make sense? Actually, this will be eliminated as well. Does that make sense? Then you do the group by, you check the timing. Meaning that all those records for rating less than or equal to 8 will be eliminated from doing the group by in the first place. That's the same to say you group them but then check at the group level. It's the same thing. Does that make sense? It's the same thing. Now, let me backtrack and change my condition a little bit. Okay, all of you follow what I'm saying, right? The two are the same, but one you check at the record level, one you check at the group level. Now I'm gonna do the following. Say not equal to. So I'm gonna use this. Can someone tell me what this query does?
Isn't that an error because
yes.
Name isn't one of the group lists?
Excellent. This actually, the underlying engine will tell you you're doing something funny. It's error. It's gonna report error. Why? As I said, having clause is to be checked at group level, and you're grouping by rating in this case, which means for each group, the name values for all sailors in one group may have totally different values. How can you check that at group level? You cannot check that at the group level. However, so this will simply give you an error, right? But really, if what you want to do is eliminate those sailors named Bob from participating in this query, you can do that at the record level. You simply do that before you do the group by. I cannot type, obviously. All right. Okay? If what you want to do is eliminate all the sailor names involved from participating in your group by in this query at all, you do this at the record level rather than at the group level. Because at the group level, you cannot check that already using the having clause. Okay? All right. I hope this example is sufficient to understand, to help you understand what group by and having does. Now that being said, group by and having is actually a very powerful machinery. You remember this guy, right? This like really ugly, like monster-looking guy, which is division, right? You find the sailor who reserved all the votes. Essentially, you're saying you find the sailor such that there is no vote he or she has not reserved. How do you find a vote a sailor has not reserved? Well, for given vote for given sailor, there's not even a reservation record showing that he or she has reserved that vote. That's essentially the logic behind this query, right? It looks complicated, but if you work through the logic, it's not that complicated. But still, it's complex, right? Let's admit it. It's complex. So, is there a way to write this without going through this expensive process? Can you do this using group by and having? A key observation is the following, which is if you are a sailor who have who has reserved all the boats. Then what can you say about that sailor? The number of boat IDs from his or her reservation records, the total number of boat IDs from his or her reservation record must be equal to what? The total number of boats in my club. Right? With one minor correction, which is if you only count the boat IDs from his or her reservation record, a person may have reserved the same boats 10 times, and I have 10 boats in my club. You will be mistakenly think you will think that this person has reserved all the boats, but actually not, right? It's just 10 reservations. So when you count the boat IDs from a person's reservation record, what do you want to do? You want to remove. Go ahead.
Make sure they're all unique.
Yeah, make sure they're all unique before you apply the counting. Meaning that you count the distinct number of boat IDs from a person's reservation record. If the total count of distinct number of boat ID equal to the total number of boats I have, you must have reserved all the boats. And that's a perfect example of group by I'm having, right? So, with that being said, how we do this work? We just say, okay, you select from sailor, because the goal is to produce out sailor name, that's why you have to involve the sailors table. Otherwise, you don't have to, right? If your goal is to just produce out sailor ID, you can do that from the reserve table itself. You don't have to get sailor table involved, but in this case, we want to get sailor table involved for that reason, right? You say you join the sailor with reserve on sailor ID. Make sure for each sailor record, you link the sailor record with all the reservation records of key authors. That's essentially what that from and where does. Follow this? And then you say, I group by the name and sailor ID. With the condition that, now, this group by is applied over the joint results of sailor and reserve. What that means is all the records concerning the same sailor will end up in the same group. In other words, each sailor gets his or her own group. And within each group, you count the boat ID from that group. Of course, you count over distinct boat ID. And you say that must be equal to the total number of boats. Okay? A final technicality is that you need, in this case, I'm including the sailor name in the group by list only to serve the purpose so that I can project this out in the end. Because projection for a group by clause must be from its grouping list. So I include sailor name into my group by clause. However, group by sailor name and sailor ID is the same as group by sailor ID. Right? In this case. Can someone explain why grouping by sailor name and sailor ID is the same as group by just sailor ID?
Because sailor ID is the key.
Because sailor ID is the key. In fact, this is something we're going to discuss later on. Mathematically or formally, what you're saying is sailor ID determines sailor name. What that means is given a particular sailor ID value, there can be only one sailor name value associated with that sailor ID. Obviously, the reverse is not true, right? This is not true. Because for the same sailor name value, you may have different sailor IDs associated with that name.
So if you were to group by sailor ID, then you would have to select from sailor ID?
Yes. Okay. To be rigorous, to be 100% rigorous, if you only group by sailor ID, then your final select clause can only be sailor ID. Henceforth, I include sailor name in the grouping list as a technicality to allow me to produce out sailor name. But it doesn't change the grouping at all. Because if sailors, for those records with the same sailor ID value, they must have same sailor name value. So they always end up in the same group regardless. That being said, today's database engines are getting better. They can actually figure out this kind of subtle correlations between different attributes automatically. So a lot of engines nowadays will allow you to do things like this. And when this happens, don't be surprised. And come back and say, oh, Feifei, you made a mistake. You told us, the project class projection, the select class must be a subset of grouping attributes. In this case, it is not, but my group by can still be executed. Okay, that's because you have this condition, sailor ID determines sailor name, and the underlying database can do those kind of deduction. This is called a deduction automatically. Ainsworth allow you to do this. Does that make sense? But the earlier constraint actually is still true, meaning that the fundamental reason we have those constraints is that you can only project out something that's universally true for the group in order to use that as output of the group by. Right? So in this case, project out sailor name, even if your grouping by sailor ID is okay, because if all records in the same group have the same sailor ID value, automatically you're going to have the same sailor name value. Okay? So that's a subtlety I want you to pay attention to. Okay? Good. Now, let's put all this together and look at illustration, right? Using our simple example, right? So this is my cross product and this is the cross product. Okay? Cross product between sailors and reserve while removing unnecessary attributes such as sailor age and reservation date. Those are unnecessary attributes, so I remove them from my cross product. Do you follow that? Then I check the where condition, because where condition is to check at the record level before you do the group by. So check the where condition against this cross product. Okay, only those two records from my cross product satisfy my where condition, which is checked at the record level. You check each record in the group by, check each record from the cross product against the where condition. Only two records satisfy that where condition check at the record level, as I have highlighted here. So far, so good? So those guys will survive this step and move on to the next step, which is to do the group by over them. So you group by them by name and sailor ID. As you can tell, I have two records and they are from two different groups. So I form two groups and I count distinct boat ID. In this case, the distinct actually has no effect because each sailor has reserved just one boat. There cannot be possible you cannot possibly have any duplicates when you have only one record in each group. So this thing has no effect in this case. Count one. Then you check against, this is the nested query, right? You check against the second SQL block, which is the total number of boats you have. I don't think we have just one boat. We have 4 boats. So after the having clause, you have an empty set. So when you do the final projection, which is the name and sailor ID, you get, of course, nothing. So no sailors are reserved all boats. You arrive at the correct conclusion using this query. Okay, so this is, in my opinion, a much easier way, a much more intuitive way of doing division. If you don't like this, if you don't like this. But it actually surprised me. A lot of you actually, some of you, not all of you, like this more than the group by having approach. Either is fine. I mean, as long as you can make your logic, the rationale of your logic work. then either is over. All right, let's look at some more sophisticated examples. All right? Find the name of the sailors who have reserved most number of boats for each winning to put into the context of Winter Olympics. Find the name of the athlete from each country who have won the most number of medals. Suppose you work for NBC, they ask you to do this work today. Right? So before today, you will be kicked back to US from Korea. After today, you can stay in Korea. If you follow what we have said today in today's lecture, right? Find the name of the athlete from each country that have won the most number of medals. That's the same as what we're doing here, right? Exactly the same. How do we do this? How do you do this? This actually bears some similarity to the earlier query, which is find the name of the oldest sailor. Why this bears similarity to that? Because there is something called the most, right? The most number of boats, the maximum number of age. That sounds like similar. And you want to find the guy who has the large value with regard to that. But there is a key difference. The key difference is in the earlier example, it's actually easier because the attribute of your interest, which is the age column, is already available from the table. So you simply do a max over that, you're done. Here, the attribute of interest, which is the number of boats, the number of valuations on boats, that's not available from any base table. That itself requires an aggregation before you can do the aggregation on max. So it's another level of nesting. Think about the movie Inception. One level of thing is not enough. Do another thing, and you're okay. If you cannot numb yourself enough in one level of game, do another level of game inside that game, and you're okay. That's essentially what's going on here, right? So, that being said, it's this. Okay? That's why I say you will be kicked back to US from Korea. Not all NBC reporters can do this. I can guarantee you that. Okay. So what we do is the following. Okay, do you want to continue now? You want to on Wednesday? Okay, let me use 1 minute of yours, if you don't mind, to explain this. I promise you I will come back and revisit this at a recap on Wednesday, at the beginning of Wednesday lecture as well. So what's going on here is, let's look at the outermost block. The outermost block, I'm saying, you're doing a join between sailors and reserve. Again, the reason you want to do that is you're interested in finding out the sailor name rather than just sailor ID. So you have to join sailors with reserve. And you group by sailor name and sailor ID so that you can pair that out sailor name. And you see, the outermost block does nothing else but link sailors with his or her graduation record. That's what it does. And you see, I only output sailor if, which is the heading, the count of boat ID. In this case, I do not do distinct because I count the total number of graduations. In fact, you can count anything. You don't have to count boat ID. You can count even just like this. That will work. But you're basically counting number of records in a group. And you see this count must equal to what? Must equal to the max of this, which is for each sailor and reserve, you join them again, but you enforce the condition you only care about those sailors with rating equal to the rating of the current sailor. So this condition links this part with the sailor of the current group you're checking. And what this gives you is for all those sailors with the same rating, that will produce multiple groups, one group per sailor, return a count, which is the number of reservations for each of such sailors that they have made. Then you're looking for the current sailor whose reservation is the max from all those groups. That must be the one who have reserved the most number of boats from the current rating. With that being said, see you on Wednesday. Hey.